common rule. Number 13, this one. If ax square plus bx plus c is the given equation, the ax square plus bx plus c equals to 0, and bx square plus cx plus a is equal to 0 have a common root, you have to show that if either a plus b plus c is equal to 0 or a is equal to b is equal to c. Okay, so you align the coefficients properly so that you can cross multiply. You write bc, ca, okay, and then you write bb, and then again you write bc. And this will be your x square part, will be your x part, your y. So by cross multiplication, you have x square by ab minus b square is equal to x by bc minus a square is equal to 1 by bc minus b square. Okay, so considering these two, you get x by bc minus b square is equal to 1 by bc minus b square. That means x you get as bc minus a square by bc minus b square. Now considering these two, square by bc minus c square equal to 1 by bc minus b square. That means square bc minus c square by bc minus b square. Okay, so that means this is your expression for x and this is your expression for x square. So therefore bc minus c square by bc minus b square must be equal to the square of this bc minus c square by bc minus b square. So now we need to show that either a plus b plus c is equal to 0 or a is equal to b is equal to c. From this, we multiply that ab minus c square by c minus b square is equal to bc minus c square bc minus b square. So now cross multiply b minus c square c minus b square equal to bc minus b square bc minus c square also square. Next part, I have ab minus c square into b square c square plus b to the power of 4 minus twice b square c. Okay, is equal to c minus b square into b square c square plus b to the power of 4 minus twice b square c. Now you multiply everything. bb into a square b square equal b c square plus b to the power of 5 minus 2 b square into c minus b square c to the power of 4 minus b square c to the power of 4 plus twice b square b c, okay, is equal to b b square c AC into b square c square. A b square c minus e to the power of 5 c minus twice a to b c square minus e to the power of 4 c square minus b square e to the power of 4 plus twice b square e cube. Okay,
Sir, y minus a to the power 5c, it will be plus.
this will be plus 1. Yes, plus 1. Okay, any other? No. What time is sine minus b square minus 1 other term. So now what to do with this? What are the like terms? A cube bc square. You have a cube bc square here, you have a cube bc square here. Okay. You have a square b cube c, you have a square b cube c. Next, what are the like terms here? Next, you have b square c to the power of 4. You have c square e to the power of 4. Yes. B square e to the power of 4. Okay. And what else? You have terms here which have not been accounted for. B square e to the power of 4. Okay. Let's take them together first, then let's see what happens. We have a cube here, and you have a cube bc square here, you have minus. If you bring it here, it becomes 5 a cube bc square. Okay. You have this here, and you have this here. So this becomes minus 4 b square b cube c. And this you have, so this you have on two sides, this actually cancels out. This one cancels. Okay. And what is left with plus b to the power of 5 minus square to the power of 2 plus twice b square b minus b square minus e to the power of 5 plus b square e to the power equal to. Next, how many terms you have? 8 terms. B plus b plus c. Can take the out, I think, of all the terms. Something to go out. A goes out, and then it will be b square b c square minus 4 b c plus e to the power of 5 minus e to the power of 4. And twice b square to a like term between minus e to the power of 4c. So this square is equal to this is 3 times 5 square 0 4 3 8 to the power of 5 minus e to the power of 4. You have plus e square
So
c cube minus
3ab, sir, 3 square bc square, not a square b square c. First one, sir.
okay, so this becomes the plus b square c minus e to the power of 4 c plus b square. Now why is it that e is between going common? Will a square go common? I think so. I think e square I can take common from all this. Not only a, I can take e square common. I take e square common. I will see 8 e square minus 4 e 3c and a only. So here I have a single e, right? I can take it out. 3 e square e square minus 4 a e cube c plus e to the power of 5 minus a e to the power of 4 plus 5 e square c minus e square minus e to the power of 4c e square that means this part will be 0 and this will simplify 3 e square e square minus I will simply multiply minus 4 a e cube plus e to the power of 5 minus e to the power of 4 plus e square e cube minus a to the power of 4c plus e square. Now, how many terms are there? There are 6 terms, isn't it? 1, 2, 3, 4, 5, 7 terms. 7 terms. The sign mistake I have made. Anyway, I'll see this the next class. Okay, but I'll like to proceed with there's a sign mistake I've made here in multiplication.
Okay, sir.
Okay, so I will send you the solution online, but the method remains the same. This cross multiplication is okay, okay, and this part is okay, but where I have multiplied here, the sign mistake. So now, what we want to understand here that a quadratic function ax square plus bx plus c, what kind of what what will it represent on a graph? It will actually represent a curve like this on your graph. This curve is actually
So
called
your voice is not coming. Your voice is not coming properly, sir. Very.
because of connection problem. Weather is bad, so that's why there's a connection problem.
Okay.
So this kind of a curve, you see the recording. Okay, this kind of a curve is called a parabola. So this curve is called a parabola. How do you get this curve? Just as you plot in case of straight lines, you write, you have your equation y is equal to x square minus plus x, y is equal to x square plus x minus 6. Okay, and you take various points. Just as in case of straight lines, you take various values. For x is equal to 3, you put 3 here, you get 3 square plus 3 minus 6. You get y is equal to, this comes to 6. You get y is equal to 6. And you take suitable points so that the points are on both sides. You take some negative value of x for this side and you take some positive value of it for this side. Okay, and you plot the points. And you join the point with the help of a freehand curve. Remember in class 10 I taught you Ojai, how to calculate the
Yes, sir.
median. There I told you to join with the help of a freehand curve, isn't it? So here also in this case,
Yes.
we join all the points. We take some points, some negative positive points from the x-axis. Just see they have done. They have taken 3, 2, 1 and 0. They have taken some positive points for this part and they have taken some negative points for this part. And then they have calculated the corresponding values of y and they have plotted these points. 3, 6, they have plotted, then they have plotted 2, 0, then they have plotted 1, minus 4, then they have plotted 0, minus 6, minus 2, minus 4, minus 3, 0, and then they have plotted minus 4, 6. They have plotted these points and joined with the help of a freehand curve to get a parabola. Okay. So remember, whenever you have a quadratic function, y is equal to, now I'm not talking about a quadratic equation. I'm not talking about x squared plus x minus 6 is equal to 0. This is a quadratic function. This is a quadratic equation. I'm talking about a quadratic function. Y is equal to x squared plus x minus 6. Y is equal to something in x. Then such a function is called a quadratic function. It will always represent this kind of a curve. How to plot? These points you find out, you plot and learn the help of behind curve. So nothing much to do here except you need to remember that any quadratic function of this form, y is equal to something in x, where the highest power of x is 2, will always represent this kind of a curve. Now this curve can be like this also. You see here, curve can be like this also. Okay. Or this curve can be like this also. Or this curve can be like this also. Okay. But the shapes will be the same for all the curves. We now come to a very important part, how to determine the sign of a quadratic function. Now before I start this, there is a very important rule that I want to know. A part of it I had done last year in class 10 where I said this is called this is called uh, method of intervals. Okay, method of intervals. What is method of intervals? Remember last year I told you that if you have x minus 2 into x minus 3 is less than or equal to 0, then I can say that x lies between 2 and 3. Remember this. And similarly, if you have x minus 2 into x minus 3, if you have greater than or equal to 0, then you can say either x is less than or equal to 2 or x is greater than or equal to 2. Okay, this is called the method of intervals for the product of two linear algebraic functions. Similarly, if I have like this, x minus 1 into x minus 2 into x minus 4 is equal to 0, then I can say from this, can you hear me?
Yes, sir.
Then if I have x minus 1 into x minus 2 into x minus 4, not equal to 0, if I have this less than or equal to 0, then I can say, see, I have one as the lowest, then the next lowest is 2, and the next lowest is 4. So I can say that 1 just need to remember this. Don't remember for anything. Just need to remember these two. That is, if you have x minus 2 into x minus 3 is less than or equal to 0, just as last year I told you, 2 is less than or equal to x, less than or equal to 3, that means x equal to equal to 3. And if you have x minus 2 into x minus 3 is greater than or equal to 0, then you can say x is less than or equal to 3 or x is greater than or equal to 0. Okay. This is what you can remember, and if you remember this, that will be enough. Okay, for the other one. Now, how to determine the sign of the quadratic? Determine the sign of the quadratic. Now, the main sums in this case will be, we just go through this sum. If x be real, find the maximum value of. If x is real, find the minimum value of. If x is real, find the maximum value. I'll show you the examples also. Look at this. Show that, question is, show that this is always positive. X squared minus 4x plus 7. You have to show that this is always positive. For whatever real values of x you take, for whatever number that you consider, this is always positive. Now remember, whenever you, and I add one more question here. The question here is, rewrite the question. Find, show that 2x squared minus 4x plus 7 always positive. Okay. And find the minimum value of x squared minus 4x plus 7. Very, very important problem, and very, very important technique that you will be doing in your class 12 also. Okay. So that this is a positive. So how to show? Start from this 2x squared minus 4x plus 7. Okay. And in order to show that this is always positive, what you do is first you take 2 common. You get x squared minus 2x plus 7 by. Okay. Now what you do is you try to express this entire expression in the form a minus b whole square. So I have a square, okay, minus 2 A, and what is, I have 2x here, right? Only B is missing. Let us take B as 1 so that I get 2x back. And what is my A? This is x. And what is my B? 1. So I take a B square. This is clear or not?
Yes, sir.
Yes,
Now that I have taken A square minus 2AB plus B square, but the expression within the bracket I have adjusted for x square minus 2x. What about 7 by 2? I have added this 1 square extra. So I subtract 1 square and I write 7 by 2 as it. Now check. This is a very, very important technique. What I have done is, this is my A square, okay? Then I need the 2AB term. So 2 I have written, A is my x, and in order to get 2x, I need to multiply 2x by 1. So this becomes my B. So now I now write a B square plus B square. But what is here? I have 7 by 2, and here I am taking a 1 square. So what I do is I subtract 1 square because 1 square I have taken extra, and I write this 7 by 2 as. Now is it clear? Now what happens? This becomes my A minus B. A minus B 1. A minus B whole square, and this becomes minus 1 plus 7 by 2. This is twice x minus 1 whole square, and then we have, if you take the LCM,
So your voice is not coming.
can you
Not
hear me now?
coming. Yes, sir, coming, coming.
Now see, you have understood all this part.
Yes, sir.
Now see, this is what my aim was, to bring this expression to this form. Now which is what? Is sum of two squares. Now can you tell me, if I take A square plus B square, Can a square plus b square ever be negative? Is it possible for a square plus b square to be negative? It is not never possible for a sum of two squares to be negative.
Will be
Sum of
negative.
two squares is always greater than or equal to 0. And when is it equal to 0? When both a and b are 0. Isn't it? When is a square plus b square equal to 0? A square plus b square equal to 0 when both a and b are 0. Otherwise, it can never be equal to 0. Right? So see what I have done here. I have expressed this in terms of a square plus b square. And a square plus b square, what is the minimum value of this expression? What is the minimum value of this expression? When this is 0, clearly x minus 1 whole square, what I was going to write, x minus 1 whole square plus root 5 by root 2 whole square is always positive. Right? It is minimum when see this is not equal to 0. So it is minimum when this must be equal to 0. Yes or no? Yes.
Yes.
This is not equal to 0. So it is minimum. This is a square, right? It cannot be negative. So what is the minimum
Negative.
minimum value of x minus 1 whole square? When x minus 1 whole square is equal to 0. That means x is equal to 1. Okay. So minimum I'm getting at x is equal to 1.
1.
At x is equal to 1. This expression is minimum. 2x square minus 4x plus 7. 2x square minus 4x plus 7 is minimum. Okay. And what is the minimum value? What is the minimum value? If this part is 0, then this is the minimum value. Root 5 by 2. Did you understand this problem? What I did was that I expressed this expression in the form e square plus. My question was so that it is always positive. So I expressed this in the form a square plus e square. And this is always positive, right? Right? This expression is always positive because I have a square and I have a square. And next question was then find the minimum value. Now minimum value, you know that if this is always positive, even x minus 1 whole square is always positive, then the minimum value occurs when x minus whole square is equal to 0. That means when x is equal to 1. And at x is equal to 1, what is the minimum value? See, at x is equal to 1, this part vanishes, this part becomes 0. Only you are left with this part. So the minimum value is 5. Okay. Now you can hear me.
Yes, sir.
You understood this problem?
Properly. Yes, sir. You have to express it in the form of a square plus b square.
Okay. You have to express it in the form a square plus b square, and then you will have to see, and then you will have to check for one. If you have to find out, if you express it in the form a square plus b square, then you have already shown that it is always positive. Now you will have to show that it is what is the minimum value. The minimum value of this expression occurs when this is all. See, this is always positive. The minimum value occurs when this is 0. When this is 0, what is the value
It
of
is
the
always
expression?
yes.
Minimum value. Okay, I will show you the other methods also. Now, in this case, follow only the problem that I am telling you. There are various standard methods. In your book, they have in this book they have